All right, okay, so welcome back. So proving the compound angle formulas. So we want to be able to take these most of the time, when you run into this is going to be probably in grade 12, some kind of an advanced functions course, and you're going to be studying trigonometry. So you have 6 different compound formulas to kind of memorize, I guess. And now the biggest thing is that where do they come from? And in order to prove it, I doubt that most of your teachers will be proving this, right? But if you get on, and if you maybe go into university or colleges, maybe someone will ask you to prove this at some point. So it is certainly in your repertoire. So you do have the tools to prove this if you've been studying trigonometry, and I'll show you that in this video. Now, most of the time we use these compound angle formulas to find out, sines or cosines or tangents of angles that are not necessarily in our standard unit circle, right? We memorize the standard unit circle with like 30 degrees, 45 degrees, 60 degrees, 90 degrees, and so on, or you can do it in radians. And aside from that, like if someone would give us 15 degrees, we wouldn't really know what the answer is because it's not on the unit circle, right? It doesn't pop out at us right away. But before I start proving this, I just want to show you, like, for instance, if you had something like this, someone asked you, okay, well, find the sine of 15 degrees or cosine or tangent. You can take this and you can break it down and say that, well, 15 degrees is the same thing as 45 degrees minus 30 degrees, right? So this would have been your theta 1 minus your theta 2. And if you look, okay, so if you looked actually, right here, then you could use this compound angle formula for theta 1 being 45 degrees and theta 2 being 30 degrees, and those are on the unit circle. So you can actually find out what sine of 15 is, right, utilizing this. Now, that's just one application. You can use others. And my interest in this video isn't so much in taking these formulas and then substituting numbers into them and then finding what the answers are. My interest here is to try to derive the formulas, right? Like, where do they come from? And my ultimate goal is I'm going to start with one of them. I'm going to try to start and prove this to you first. And then from this, so I'm going to copy this. From that, I'm going to be able to get the other ones, right? Kind of one by one. I'm not going to solve and prove every single one, but I think once I do the first one, I'll show you the second one, and I'll do one of the sines. Then I think you're going to catch on, and you're going to be able to do the rest of these on your own. Okay, so let's get ourselves started. So how do we begin? Well, I'm going to begin with the unit circle. So our ultimate goal here will be to try to prove this. Okay. Now, if I take the unit circle, I'm going to start to construct. So first, okay, I'm going to take, for instance, let's say an angle. I'm going to take it like this. So this is going to be my first angle, so this one right there. So if I go like in this direction, and I'm going to call that, let's say, theta 1. All right, so that this is going to be theta 1. Okay, so this angle. So this is, the length of this is just 1 because it's the unit circle. Okay, and then there's my theta 1. Now, I'm going to construct theta 2. Now, for theta 2, so what I'm going to do is I'm going to kind of go right here. All right, and let's say, okay, so from here to here, so if I go in this direction, okay, then this is going to be my theta 2. So let me kind of do it like this. So this would have been theta 2. Which means that if I wanted to find what the angle is, so theta 1 minus theta 2, so that's the subtraction of the 2, then that would have really been just this right here, right? That's what it should have been right there. This is theta 1 minus theta 2. Okay? So I'm just kind of constructing this out. Now, if I construct this and I connect these things, so notice if I go right here, then I have just constructed a triangle. And we know sines and cosines are always ratios with respect to these triangles. So we can use some of these tools we had in the past. Now, okay, I will write, so the length of that is 1, because again, we're on the unit circle. But I actually don't know what the length, okay, of that piece that I've created there, that last piece is, because I don't know what the angles are, okay? So I have basically, one side, I have another side, and I know this angle is, right here, it's theta 1 minus theta 2. Which now reminds me that, okay, well, wait a minute. So here, what it looks like I have is I have side, angle, side of a triangle. And for side, angle, side, I can very easily use the cosine law, right? So with respect to the cosine law, okay, so, for our cosine law, so what I'm going to do is I'm going to say, let's call this length, okay, so this length that I created on top there, I'm going to call it C, all right? So that's going to be the length C. And now for the cosine law, so if you recall, so this is going to be C squared is equal to, right? And I can now call the other ones, okay, so this is going to be A squared. So those are the lengths, right, of the other sides, B squared. Now I know those ones are equal to 1 because they're just unit circle. And then this is going to be minus 2AB, and then this is the cos of that angle, right? And that angle is, for me, so that's the angle of C, okay, which turns out to be theta 1 minus theta 2, which is what I'm trying to find out what that equals, right? I'm trying to find out what cosine of theta 1 minus theta 2 is. So that's from the utilization of the cosine law. Now, again, so what I'm doing is this is A, this side is B. I know those sides are equal to 1. So I can simplify this. So this is going to be 1 squared, which is 1, plus 1 squared, which is 1, minus 2. And again, so this is just 1 times 1. And then cosine theta minus, so theta 1 minus theta 2, right there. So if I simplify this, so it's going to be 2 minus 2 cosine theta 1 minus theta 2, and that is all equal to C squared. Okay, so the length of that unknown side. So that's the first thing that I'm going to do in my derivation and proving of this compound angle formula. Now, I know a little bit more about that C. I can find that C from, okay, the fact that I actually know, okay, what those points are. So I know what this point is. This point, because it's the unit circle, this is just nothing else but just cos of theta 1, right? That's the x value. And this is going to be, so the y value is sine of theta 1. So that's that point. And then the other point, which is this point, so I also know that. And that is equal to cos of, theta, this is theta 2, and then sine of theta 2. So that is just understanding that on the unit circle, the x values are cos of the angle, and the y values are sine of the angle. So I know those points. And if I know 2 points, I can find out what the distance, right, what the length between those 2 points is, right? This is going back to kind of using Pythagorean theorem, right, between 2 points. So if I knew what those 2 points are, I could find out exactly by using Pythagorean theorem. Now, how? Well, in order to be able to find that, then what we're going to do is we're going to find the length. Okay, so this is kind of the length in the x direction, and then this is going to be the length in the y direction, right? So here we go. Here was our Pythagorean theorem. So we know that distance on top is just cos theta 1 minus cos theta 2. That's the distance between the x values. And then the y value, the distance, so sine theta 1 minus sine theta 2, is that other distance. So what I have here is I have kind of the second thing that I can utilize. So I'm going to write it down in here. So what this is, maybe I'll switch color, I'll just keep it as it was. So that means that c squared, because I'm using Pythagorean theorem, right, is the distance in the x, right, so the length in the x squared, plus the length, okay, in the y squared. But these are just points. So this is going to be cos of theta 1, right, minus, okay, this is again cos of theta 2. So that's my distance in the x. My distance in the y, so this is going to be plus, okay, is going to be sine of theta 1 minus the sine of theta 2. Okay, so both of these are squared by Pythagorean theorem. Now, once I know that, let me simplify this, right? So let me actually do the squaring. So what this is going to be, I'm going to take the first one, so the coses, and square it. So I'm going to get cos squared theta 1. Now minus, so if you expand that out, it's going to be 2 of cos theta 1 times cos theta 2 plus cos squared of theta 2. So that's this. I've just done that. Now if I do the same thing and I expand this out, then what I'm going to get is I'm going to do that just below. So that's going to be plus, right? So plus. And then I'm going to get sine squared theta 1 minus 2 sine theta 1 sine theta 2 plus sine squared theta 2. So that's the expansion of that one. Okay. Now, this goes back to, trigonometric identities now. And this right here, because this is just addition, so cos squared plus sine squared of the same angle, we know is equal to 1. That's an identity, right? That's a trig identity. So that's just equal to 1. So this is going to be 1 from there, okay? Now, the rest, okay, I also notice that on the other end, right here, this is cos squared plus sine squared, again of the same angle, except it's theta 2. This is also equal to 1. So this is going to be 1 plus 1. So that's these two things out of the way. And then what I have remaining is I have minus 2 cos theta 1 cos theta 2. So that's this. And then minus, and this is going to be sine theta 1 sine theta 2. So that's right there. So that's what we have from those two. So this is 2 minus, okay, so all of that, right? So I'm going to just copy this down and duplicate it below. So that is equal to c squared, right? So that's equal to c squared, what I have been doing all along. Now, notice, so I have two things for c squared. I have this, okay, I'm going to duplicate that, bring it down, and this is equal to that. Okay, so these two are equivalent. So one is on one hand and then one is on the other. Now, if I take this, because they're equal to each other, so let me rewrite this and then just do the algebra. We're going to find out exactly what we need. So I'm going to rewrite this. So we have 2 minus 2. I'm going to try to squeeze it all in here, is equal to 2 minus, okay, this is going to be 2 cos theta 1 cos theta 2 minus 2 sine theta 1, I'm running out of space, and sine theta 2. All right. Now notice on both sides, so what do I have? 2 and the 2, so that will cancel. Okay, so that's gone. And now notice dividing both sides, so I can now divide both sides by -2. Okay, so divide this by -2, and what am I going to get? I'm going to get cos of theta 1 minus theta 2, which is exactly what I wanted. So the -2, okay, it's going to cancel these two out, and all I have left is cos theta 1 cos theta 2, all right, plus, because the negatives are canceled, sine theta 1 sine theta 2. And there you have it. So now you have proved, so you have derived the first compound angle formula. So for cos theta 1 minus theta 2, and if I go back here to the table, you'll notice that this is exactly what it is. So this is that. So it's just cos theta 1, cos theta 2 plus, the sines of the angles. So there we have it. That's derived. Now, if you wanted to find out, because now the rest is actually a little bit easier. So if you wanted to find out what this is, right? So the addition one, well, so we don't have to go through the whole junk again, okay, in order to derive it, because I can kind of manipulate and say that theta 1 plus theta 2, really, I can rewrite it like this, minus, okay, and then negative theta 2, all right? Now, if I manipulate it like this, where this is my first angle minus my second angle, I can actually use this compound formula, right? So I can use this whole thing, so substitute it back in here. So notice if I substitute it in, with this is going to be my first angle and this is going to be my second angle, what I'll get is, this is going to be cos theta 1. Now substituting, I'm going to get cos of negative theta 2 plus sine of theta 1 multiplied by sine of negative theta 2. But wait a minute, we've done these before. We know that cos is an even function, and because cos is an even function, this is going to be cos theta 1, cos theta 2. And we know that sine is an odd function, so because of that, this negative that we have in here can come out in the front. So I'm going to just do it. So this is going to be negative sine of theta 2 because it's an odd function. So the plus and the minus is going to yield for us exactly what we want. And that's going to be our second angle, so compound angle formula. All right. So that's going to be that. So the only really difference is now you just have a subtraction there. So there we have it. So we've now, from our table, if I go in here, so we've also now derived this. So we have, our coses are gone. All right. So those are, two things that are now finished. Okay. Now, how will I find the sines? Do I have to go through, this unit circle and so on and maybe use a sine law or something like that? No, not really. Okay. If you wanted to derive those sines, so I'm going to go back in here. I'll switch my color. So if you wanted to derive one of these, let's say sine, and it doesn't matter which one we take. So let's say the addition one. You can do the same thing for the subtraction one. So within here, I'm going to actually use another equivalence. And, you may remember, so this is the same thing for odd and even. I talked about these equivalences. Maybe I'll put up a link to this in case you've forgotten it. Okay, it was part 1 and part 2 videos. I'll do the link to part 1 and then you can watch the part 2 as well. So those are about equivalent trigonometric functions. All right, so I'll put up a link up above there in case you need it. But what I'm talking about there is that sine of an angle x was equal to the cos, so this is the complementary function. So cos of 90 degrees, or pi over 2, minus the angle itself. So these are equivalent. Now, why am I doing this? Is because I've just derived cos, right? So I have both cos there. So I have it right here, and then I have the addition one right here. So that's why I'm just going to use now the equivalence right there to get what I really want. So sine of the angle, so let me remove this. Actually, I won't remove it. I'll leave it there for you so you can see what I'm doing. So what I'm going to do is I'm going to say sine of theta 1 plus theta 2 is equal to cos of 90 degrees, right? Minus, okay, of that angle, theta 1 plus theta 2. So that's my angle. That's my x. Okay, now I do need one more little trick here. What I'm going to do is I'm going to say cos Okay, and now I'm going to bring in this negative inside of the bracket. And if I bring in that negative, okay, I'm going to get two angles. I'm going to do this. I'm doing this on purpose. All right, minus theta 1. And then I'm going to get, so if I bring the other one, this is going to be minus theta 2. And these are now my new angles. So one angle minus another angle. And now I can use the complementary, so I can use this right here. So where is it? I can use that. Okay, let me copy this, bring it down. Okay, except my angles are the ones that I highlighted. All right, so if I do that, I'm going to get, so I'm actually expanding this out. So this is going to be based on this. So this is my angle 1, this is my angle 2. So this is going to be cos of 90 degrees minus theta 1 multiplied by cos of, okay, this is theta 2 plus, this is going to be sine of 90 degrees minus theta 1, and then this is going to be sine of theta 2. But, once again, okay, this is from right here, okay, so utilizing the same thing as I did for sine, so this is the cofunction. So based on the cofunction, this right here is just equal to sine of theta 1. So that's going to be cos of theta 2 plus this right here, again, by cofunction, this is going to be cos of theta 1 sine of theta 2. And there you have it. So that is my sine theta 1 plus theta 2. Okay, so if I go back in here, so I've now found this one, okay, the addition one. And I can do the same thing, okay, on the opposite side. So I can say, you know, theta 1 minus theta 2 and do the same trick, okay, and that's going to give me this, all right? So I can separate that. I can say theta 1 minus, you know, it's going to, you know, you can take that out, okay, and replace it, okay, just as we did right here, with what we needed. Okay, so there you have it. All right, so now for the tangents, you can do the same trick, because now the tangent of theta 1 minus theta 2 is just division of sine over cos, and then you can just manipulate it, okay, to get both the numerator and denominator. So it'll be a little bit of, you know, algebra there, and you can do that for addition. So that was my goal of this video. So the goal was, really the biggest trick is this. Once you have this, you know, you can use some of your other tools that you've utilized to be able to prove these. It's not that simple, right? I mean, now that you look at it, I don't know, you know, if by looking at it you'll understand the whole thing. You eventually do have to sit down and kind of do the proof from scratch on your own, and then manipulate it to be able to see what it is. You know, but if you were just stuck and nobody told you what to do, it would be hard. All right. Now, that's it. Okay. So I'm not going to talk about much more. You know, here is the summary of all of them. At the end of the day, most students and teachers included will simply use these, you know, to try to apply it to some questions. But it's always nice to know where the heck these things are coming from. So there you go. All right. So hopefully that is helpful. Okay. So thanks for watching. We'll see you in a future video. Okay. Cheers. Bye, everybody.